Hello and welcome to this session where we'll be reviewing the risk estimation method, and that will be in the context of ClassView Connect. So this is not a complete review of ClassView Connect. Now we are looking specifically at the risk estimation component. So risk estimation has been in ClassView Connect and in some of the other components, and a recent update involves an abstraction of this risk estimation method. And with that, there has been a significant upgrade to risk estimation. And this component, now that it's abstracted, will also be useful in other areas. So you'll also be seeing it in the program analyst and executive insight for analyzing risk at the whole course level or whole academic program level or whole institution level. So at the moment, let's just look at it in the context of student risk estimation. We will be looking at the Scholar Cloud implementation. So there is this is a simulated institution. And so when you see names and student numbers, those are not of real people. So let's go ahead. So under the student performance section of ClassView Connect, we would go ahead and say load data. So that's loading up the risk data associated with this course in this year. And again, that's of simulated data. So in this case, there are many thousands of records. There are perhaps 5 different assessment records. And so, yeah, 5 different assessments and many records that need to be loaded there. But once that loads, it will show first here your statistics for each of the assessments. So it's giving us the mean and standard deviation, the number average based mean. So if you are familiar with distribution functions and the moments, then that's also the number average mean. The number of students, of course, the minimum and maximum marks, also the skewness and kurtosis. So those tell us a bit about how closely the data follows a normal distribution. So, of course, in dealing with means and standard deviations, we very quickly start thinking that everything's a perfect normal distribution. But if you look down here, you see this plot of the actual data. So the blue dots are the data, and then the yellow line or orange line, I guess, that's a plot if we were to just use the mean and standard deviation. So you can see it doesn't follow exactly a normal distribution. There are data points that dance around that, but those are the summaric statistics there. We can use the skewness and kurtosis to improve this line, and that may be factored into things as we go. So right now, that's the mean and standard deviation. You can also see on the right here, high performing students, low, and so on. So we'll get to that. But here, among our statistics, so we've got the statistics there. Also, if we want to view the raw data, then we can click under vals, and then that so the bold one is the index position. So that's just an index, and then the unbolded ones here are the actual values. So those are marks by these simulated students, and that's behind the distribution that we get here. So this is a frequency distribution. These are not actual marks. This tells us, so for instance, this point, it tells us that for a mark of 70, of about 71, this is the frequency value associated with that. Okay, so that's the frequency distribution there. And then, of course, if we click on any of the other distributions, then we can view their stats as well. So you can view the summaric statistics for each of the assessments. And then here's what we are actually looking for. So the high performing students are listed here. So if you click on view all results, I don't know why I'm zoomed out. So if you click on view all results, then it shows you the results for that student. And you can also see Z values here. So Z is the number of standard deviations above or below the mean. Positive is above and negative is, of course, below. So here, a student has a result that's more than one standard deviation above the mean. So we know this is an unusually high mark. So that's a good mark there. And then there is one which is slightly below the mean, well, in two places, but very slightly. So we don't raise an alert on this. So that's under high performing. If we look at low performing, so our students who might be at risk, and if we view their result, then you can see there are some records that are significantly below the mean, right? More than one standard deviation below the mean. And you can see in the report here, POS and NEG, of course, positive and negative comments. So there are 4 negative comments here. And if you look under high performing, if you view their results, then you can see positive comment there and no negative comments, right? That's an empty list. So that's how we can read these. That's how we can interpret each student. So, so you've got low performing, high performing, and you can also look at all the students here. And if you want to look up the results of any particular student, then you can start typing in this filter bar. You can start typing the name. So ROB, for instance, here, that's giving us, okay, Robinson. So we can filter down the list very quickly just by typing in here. Typing by student number will also work. So you can really filter this list quite easily. Okay, so that's the list of students. We can also download all this data. So if you look here, we've got, sometimes this table breaks a little. And it depends on the sizing. Okay, so if you size this the table correctly, and then sometimes it will overrun. So there's that. So you've got all the raw data available here. So this is the original data set without any of the Z values being calculated and so on. So if you look at source data, then that's purely your assessment records in there. And so if you move along here, you can see those are all purely the data about the assessments. And then you have underneath that processed all data. So that has the same records, but now it also has the string for the reports, and it's also got the Z values for each of the assessments. And you'll also see a couple of other counts here. So this is the number of positive comments from the report or stored in the report. That's the number of negative comments in that report. That's the net. So if we take the positive comments, the number of positive comments minus the number of negative comments, then that's the net number. And then, of course, we are ranking the students using that net index. So here, for instance, you can see an unusually low net value. That means many more negative comments on the student. And so this is likely classified as a student at risk. So that's what's behind these reports. And we can download these just by clicking on any of the download options here. So you can download the source data or the process data for all the students, or the process data for the high-performing students, or the process data for the low-performing students. So that's all available there. Okay, and let's just come back here. So that's downloading. And then if we want to change our criteria, so looking at the meaning among using the standard deviations and so on, your risk settings are shown here. So the risk settings, these default values, have been used in generating these assessment statistics and all these lists as well. So if you want to change your criteria, you can do that here. So just to explain what these options are. Number one, your minimum value alert. So if you want to raise an alert on a mark being below 50%, then you can set that here. So you could consider that that is, in a sense, double counting, because if a mark is unusually low, that will already be counted. So you might want to switch this off. So you could raise an alert on a mark going to less than 50%, but if you type here false, then that will also prevent that check being done. So that's how you can switch off some of these criteria. So again, this is if we want to raise an alert for a mark going lower than a value specified here. Another setting here is that if our mark is above a certain value, then we might not want to raise any alerts on that mark. So for example, if we have an assessment with an extremely high class average, maybe the class average is even 90%, then in that case, even if you get 85%, you might still be seen as significantly below the mean. And so to prevent a situation where we have, in a sense, silly messages or silly alerts coming about because we are not checking the absolute value, then we can adjust this. So we are saying here, if the mark is above 80%, then don't worry about the fact that that the mark might be low in comparison with the mean, right? Perhaps we are 2 standard deviations below the mean, even though our mark is maybe 81%. So we can say here, if the mark is more than 80%, then don't worry about the comparing it with the mean or anything like that. So you can switch off a certain check in that way as well. Then maximum standard deviations. So that tells us, or that's the criterion when we want to classify students for a positive comment. So if we want to raise an alert as a positive comment, if we want to say, yes, this is an unusually high mark, then we can set that by comparing with the 1. So if the mark is more than or equal to 1 standard deviation above, then that 1 is set here. So if you don't want to classify students as high performing on a 1, if you want it, for example, to be 2 standard deviations above the mean or 1.5 standard deviations above the mean, then you can do that here. Then this also raises negative comments. So when we have students who are more than 1 standard deviation below the mean, then this is where we specify that 1. So if we want to say only raise negative comments when we are below, for instance, -2, so we are 2 standard deviations below the mean, then we can adjust it and make it a 2 here. So we can modify our criteria here. Include zeros. So sometimes it's the case that at the institution, an absent student, so a student who didn't take the assessment, is marked as a 0. And if we know that students don't really get 0 on an assessment, and that this is likely just because a student was absent, then we can say, no, don't include the zeros. So that's how we can change that. The result fields here, this is where the Autoscholar has spidered through all our assessment data. It's figured out these are the names of all the assessments that were written. And so it's recommending use all of them and check all their Z values and all these other tests here. But if you want to omit an assessment from this list, then you can just edit it here. Right, so that's, result fields. And then we saw earlier that the report it was generating was being stored in an additional column, which was called report. And then if for whatever reason you want to change that, maybe in your data set, you already have a column called report, so you want to call this something else, then you can change the name here. So you can amend all your criteria here and then click Evaluate Risk. And then it will work through the data and regenerate your lists of students here. You wouldn't, of course, see any change on this side. So these are the basic statistics about all the assessments. Those statistics are not going to change. These things don't change the distributions of the marks as they are. So this will only change your lists of students here. And so you can change your criteria. And I see we actually don't have any low performing students anymore because of the changes we made to the risk settings. So that's how we can adjust our risk, or that's how we can control and interpret the risk results that we get in the AutoScholar. As mentioned at the start, this is now abstracted. So the risk method and all this entire interface, this is now in an abstracted method, and it will be applied in all the other types of objects in which we want to estimate risk. So you'll be seeing this method a few more times in some of the other components. Thanks for listening.